All right. Hi, everyone. Welcome. Thanks for coming on a Friday night when you shouldn't have anything better to do. Today, I'm going to talk about CoreDNS. I have the Zoom chat open on another screen, so you can send me anything in there, and hopefully I'll get it. But yeah, first I want to start with just a little DNS primer. So if you're an expert on DNS, feel free to grab a cup of coffee, say some things in chat, talk amongst yourselves. That's fine. But I assume there's going to be people here who don't know a lot of things about DNS. So I'm just going to cover a lot of the basic things, the things that I work with in DNS a lot. There's other things that I'm just going to skip because I never do them. First, some tooling. Dig is a command line program that you'll want to install if you don't already have it. It's for doing a lot of debugging DNS entries or DNS records. So if we were to just dig RocDev.org, this is the response that we would get back. It would tell us that RocDev.org is an A record. We'll get to what A means in a second, pointing at that IP address. So if you were to just load 104.236.88.86 in your browser, accept the HTTP certificate because it'll probably mismatch, you should get RocDev.org, just the same thing that you would get going to that DNS entry. Also, going down a little bit to the server section, we see 192.168.86.1. That is the DNS server that is responding. That's my Wi-Fi router at home. And pound 53 is telling us that DNS is running on port 53 there. You can also see the date that I made this presentation, this deck. It was on April 7th at 8:30 p.m. All right, so some basic record types. There's really 6 that are common that I use, and really even number 2 is not common, but it will be. So first, we'll just jump into A records. Those are the simplest ones that I showed earlier, where RocDev.org is just pointing right at an IP address. An IP address, you can't get any simpler than that. That is the machine. That is how you route to it. Also, if we were to dig google.com, we would get a single IP address, 172.217.4.78. Google's doing something a little crazy with multicast IPs, and that is outside of the scope. But when I dig this, I get a single IP address. Four A's version of an A record. IPv6 is supposed to be the future. In previous A records, these are IPv4. IPv6 has a bunch more addresses, and because of that, they look a lot more complicated. No one's ever going to remember any IPv6 address and then write it down. It's just too long. But if you were to do dig and tell it to give you a quad A record, and I'll show you how to specify which record type in a minute, it would give you this, or at least it did. It'll probably cycle a bunch because they're also doing geolocation-based DNS resolution. So when I did dig this a couple times, I did get different answers, probably for some latency optimization. And here we can see how to specify the quad A record. So if we dig google.com and say we want the quad A type, here's what we get. CNAMEs. I'm actually no longer using SparkPost, but the DNS record is still there, so I'm glad it was. It gave me something to test. If I were to dig bounces.rocdev.org, that is a CNAME, a common name for sparkpostmail.com. Like an A record, it points to one thing, except that one thing is another DNS entry. And then if we were to follow dig again for sparkpostmail.com, that should go somewhere as well. And then there's another section, the authority section. We'll get to this in a minute. Spark Postmail's start of authority is not my domain. It's actually somewhere on DNS. And we'll get that in a minute. MX records, this is for email. So again, if you were to dig RocDev.org with MX, you would get in1 SMTP messaging engine.com. If you were to look up what that is, I'm using Fastmail for RocDev. So any requests that are going to RocDev.org, sending it email, it'll go into my Fastmail via this SMTP address. Text records, these are fun. It's really just a key value store. So if you were to check RocDev.org's text records, you would see a couple of them here. Probably should have spaced those. When you're validating that you own in a domain, like with this Google site verification, you can put them in text records. This is also how Keybase checks that you own certain domains. They give you some kind of a token. You put it up in your DNS, and then they'll scrape it and check for you. But really, kind of a stupid thing. If you follow Corey Quinn on Twitter from the Duckbill group, he built a database using Route 53, Amazon's hosted DNS, using a bunch of text records, because it really is like a key value store. You can put anything in there that you want and just have a bunch of data. Mark is telling me something, okay. SRV, service records. These ones are only common if you're doing microservices, as far as I can tell. I really haven't seen them outside of this. Why? They allow you to specify a lot of data in one record. So they all follow this kind of pattern. Underscore service, like some service name, underscore proto, TCP or UDP, and then a name. TTL is time to live. How long does this record last before you should recheck it? So that allows you to keep a client-side cache of it. All DNS records have a TTL. Class, this is always in. There's really no other option. It's a service record. And priority and wait are allow you to specify multiple of these. So if you have 3 microservices that are all doing the same thing, they're all, I think this one was named SIP. So if you have 3 of these, priority says, hit this one first, lowest is best. And then you can have multiple other ones that are kind of like fallbacks. But if 2 of them have the same priority, it'll then say which one has the most weight. So that's the next one. So here we have 0 for priority and then 5 for weight. And then the next entry is the port. So if you have that service running on a certain port, but maybe that server or that exact container, if you're running Docker, exposes multiple ports, and you have different service records in each listing different ports, 50, 60 for this one, and then the target. So I mentioned briefly before the start of authority, the SOA record. Each DNS service or each DNS server can be authoritative or just forward on to another DNS service. So like if I were running, or I'm running a DNS server on my router, just like everyone does by default, that isn't acting authoritatively for RocDev.org. It doesn't have the entire hosted zone for RocDev.org, so it has to pass that along. In order to find where the authoritative server starts, you issue a SOA request, and that will tell us that I am using Cloudflare for my DNS. Cloudflare is just a pretty good service. It's free. Hashtag not sponsored. Yeah, so you can see Cloudflare is what I'm using here. If you're actually, this came up today at work. If you want to know, do we have our DNS records in the on-prem DNS server, or are they just in AWS and Route 53? When all of your VPN traffic is going through that local DNS server, if you issue a big URL and SOA, that'll tell you whether or not your local server is the authoritative server, at least if it's acting that way, or if it's AWS, Cloudflare, what have you. One thing that is kind of annoying with authoritative responses, and why you want to do SOA requests to find out who is, if your local DNS server caches the host or the zone, then it can say that it's authoritative even though it's not. So if you always want to find the true start of authority, issue a SOA. So I said a word zone. Zones can get kind of complicated, but really just think of it as the domain for which your server claims to know something. This would be, so we'll see zones when I do live coding next. It's essentially just the DNS name. So like RocDev.org would be a zone. I could also make a subzone like test.rocdev.org, and I'll show that too. And then inside that zone will be a bunch of DNS records. All right, so I'm going to do some live coding, which they always tell you not to do, but we're all in this together. If you want to skip ahead, back on April 7th, I did fill out all of this, so you can download this repo and play with what we're going to end up with. All right. Let me check back, make sure nobody's trying to get in and I've ignored them. Perfect. One person. All right. I should still be sharing my screen. I see that. Let's make this a little bit larger. Anthony points out in chat, Active Directory makes very heavy use of SRV records too. Thank you. Can everyone see that text, or should I attempt to make it larger?
Larger.
Why isn't it getting larger?
Enhance.
Not registering Command Shift Plus. What is this? What is this thing doing? This is what I get for trying a new terminal. Hold on. Let me just close and reopen it. Huh. Well, that's annoying. All right. All right, we'll bring in my turn so he knows how to get bigger. How's that? I assume good. No one's complaining.
Yeah, it's better.
Oh boy. Let's just keep going. Enhance. Perfect. All right. So CoreDNS, let's actually hop right into CoreDNS here. CoreDNS is one of those cloud native tools. So I find it fitting to put it in Docker. So let's start with Docker Compose here. Get some boilerplate out of the way. We'll call it CoreDNS. We'll build that from a local directory that I'll also call CoreDNS. Now, ports. It's going to serve on 53, but that's not going to work on my Mac. So let's just do a bunch of 5s and a 3. We'll do both TCP and UDP. All right, so we'll get rid of that, and then we'll open up a Docker file. So this we'll do from CoreDNS. I just happen to remember that. Let's expose some ports. 53 and 53 on UDP, just a good habit. And we'll copy, this will tell us the next thing that we have to do, the core file. So CoreDNS is configured with a single core file into Corefile. And we'll set the commands. We can put that core file anywhere we want, but I'm gonna put it right at root. All right. So now, what should our core file look like? Okay, so Corefile or CoreDNS is broken down into plugins. So we're going to say for all records, and that's what that dot means, it's a big wildcard for a zone. We're actually going to forward to Cloudflare. Why not? We'll just start there. If we do a Docker compose up -- build, hopefully it works. Oh, of course, I got to download that. Oh no. Yes. Okay. This is live coding. I forgot to tell it to forward the entire zone. So with the forward plugin, I can tell it to only forward a subset, or I can tell it all the things. Since I'm starting basic right now, all the things. Let's actually split that. Okay, so if I were to dig, let's just go straight to 1.1.1.1, or quad 1 for short, we get what we expect, right? And we see that the server was quad 1. But I can also dig, we'll do devs.org. I can specify which port for dig to use. So I'm running CoreDNS above on 55,553 at localhost, because I published it to localhost, and query the same thing. So here we see we hit localhost 3 or 4 5s and a 3, and we got the same response back, which is what we expect, including the same TTL 305 5 minutes. So okay, let's clear that. Let's get a little bit more complicated with our core file. Cool. We want, well, let's jump down. Let's test a little fun one that CoreDNS gives us. So we can get some information about CoreDNS itself with two special zones, version.bind, version.server. And I don't know why, but the name of the plugin is Chaos. Cool. I wish I knew why. No. What did I? It's supposed to give me more information here. This is live coding. Oh, did I? What if I spelled that wrong? So there's other fun ones. Good thing I took notes on this one. Why does this don't show again? Interesting. Well, I'll get back to that, I guess. There's one other fun thing that recently came out of Cloudflare. If you're looking to run your own like Pi-hole or something like that to block bad traffic, you can actually use 1.1.1.3. There's different levels. There's 1.1.1.1, .2, and .3. That'll give you some interesting differences. So if you were to search for bad websites, like if we go to RocDev, if I spell it right, RocDev.org, that continues to work. But if I were to look at bad sites, I get nothing back, right? So it's blocking that for me. So that could help for those with kids. So I'm going to keep that in. Let's see. So another
that too
thing
doesn't do the adult sites for anyone who's interested. It just gets rid of the malware.
Oh, nice.
Wait, did Dennis just share tips on how to watch porn? Like, did I hear that correctly?
No, how to not.
Okay.
If you use 3 1s and a 3, you will not be able to resolve any bad sites.
I see.
Your DNS will just essentially black hole, and you'll get 0.0.0.0 for every bad response. Let's see, a couple other things, like we can, where am I? I was typing that somewhere. Oh. Errors plugin and the log plugin do exactly what you say. If you send it bad requests like that, it just can't handle, it'll dump those out, and also we'll get a nice, we'll get log messages. I keep doing that. So yeah, now we're getting these info messages every time we make queries. All right, but in the world of container or cloud native, right? You really can't survive without health checks, right? So I'm going to toss in a couple let's see. I'm going to do this. Then we're going to do, we're also going to do readiness checks. Health and readiness, different things. Health is just saying, am I alive? Can I take traffic? And readiness is, am I actually ready? And in CoreDNS, that means, are all of the plugins that are used, are they reporting as able to go? For errors in log, they're so basic that readiness should always work. So I kind of hope it does here. Towards the, in the future steps, that'll be a little bit trickier. We'll see. Let's see. Go into our Docker file. Let's add a couple of environment variables there to match what we did there. Health port equals, I want 8080 for that one, and we'll do readiness port. Let's do 8181. All right. And what we're going to have to do now, in our Docker compose file, we're going to have to mount those ports or publish those ports. So let's see, we told it that we want 8080, that should be fine to run here. Protocol, TCP, load host. And I am doing this in the long form because I find the short form can sometimes be confusing if you've never used this. All right, so now if I do Docker compose up, we'll find out if I mess it up. All right, we'll start by hitting the readiness endpoint, and we got 200 OK. Whoops, oh, right, because we put health on 8080. So this is kind of where those SRV records can come in. Oh, that's cute. Whatever. But it is ready. So I'm running one CoreDNS here, but I could have multiple SRVs for each of the ports that CoreDNS is serving. They all kind of serve a different purpose. All right, so we have health and readiness. Now, what's the other thing that we need all modern cloud native things to support? Prometheus, of course. So we're just going to do the same exact thing that we just did. Add in the Prometheus port. Add it to our Docker file. I'm going to do this on 9153. Normally, I would also add those to the exposed line here, but and in the GitHub repo, I did. Let's do this, and we'll add 9153 here. And if you're familiar with Prometheus, this is what the Prometheus metrics endpoint always kind of gives you. We have the key of the metric, the label, and label's something else in Prometheus, and the value, so that's a really low process start time. And we have some nice documentation to tell you what each of them is. It's written in Go. CoreDNSs, so you get all these nice Go stats for free. Then we get some CoreDNS specific ones, health. So if I were to call the health endpoint, I should get some of these, each of those buckets. And here we get some CoreDNS build info. So it's running Go 1.14. CoreDNS version 1619 or 169. That's what I was expecting to see when I ran a dig on version.bind. Should have given that. Maybe they updated something. Okay. So there's a couple of other fun little plugins. And luckily now we only have to modify this. So I'm going to use example.org. We're all thinking com, but no. Okay, so I'm going to copy the ready plugin because the ready plugin has to be used in each zone for which you want a readiness check to be available. But now I'm just going to do who am I? So now this will give us who we are making or who the client is making the request. So we can see that I'm coming at it from 172 IP address. That's kind of nice, kind of like gives you an echo to kind of just test if you have your CoreDNS setup going. You can run the metrics endpoint still. You can check its readiness. That's cute. I seemingly broke that. I guess it's not ready. What did I change in that amount of time? Huh. Anyway, wonder. Learning together. Huh. Oh. Help if it were running. Maybe not. Hey, what happened there? That's not the right directory. I'm just going to run a Docker compose PS. Well, the ports are there. I bet if I ran my example repo, it would work. Maybe I'll do that at the end. All right. Either way, let's add some more to the Corefile. So we got a little who am I check. We can also do erratic. This plugin is kind of a jerk, and that's its point. So we can introduce delays. We can say, like, for every 5 requests, introduce a 50 millisecond latency. Drop every 3rd request. Truncate them. Sure. So that way they don't give you the full response back. Oops. So like this should fail. It took a little longer to respond. It'll always return with 192.0.2.53. That one came back quick because none of them happened, or none of the plugins tripped. Now we're getting another delay. So we can make it fail. I wonder if it'll work this time. Nope. All right. Something's weird there. That still goes. This is going to kill me now. I wonder if I have something else running that I didn't remember. I'm going to check real quick. So I should have Kubernetes CoreDNS. Yeah, only that one. Anyway, all right. So let's see. Let's do a couple. Let's do a local file. Actually, let's start with Route 53. So we have all of these kind of like testing configurations. Let's say we actually have a real one. And here, you might be able to see, let me get a little bit bigger. I have in Route 53 in my own AWS account, I have a text record and an A record, foo.test.rocdev.org, and for both of the A and the text. So move that just over there in case you want to see it. Let's use the Route 53 plugin. It's built in. Test.rocdev.org is the name of the hosted zone. I wrote this down, so I'm just going to copy it and paste it. Here's my zone ID. And in there, we have to give it my AWS credentials. In my AWS credentials file, I have multiple profiles, and the profile name is personal because it's my personal account. I'm going to tell it to refresh every 5 minutes, and I'm not going to do the next one yet. We'll build up to that. Okay, so one other thing that we have to do is we have to tell it how to get my credentials. So in our Docker file, let's do it up here, volumes, AWS credentials, maps to, that's what we call it, AWS credentials. Sounds right. Let's check in. All right. Oh, I wonder. Yeah, all right, that's probably why. Anyway.
George, quick question in the chat.
Yes.
If you want to look at it.
Oh, sorry, I didn't go too far. Mark Manning, let's see. This is the Chaos plugin causing latency and failness. Erratic would be the one that does all of the latency and failness. Oh, hold on, I'm getting one more. Participant? Nope, okay, never mind. Well, act like terrible DNS. So yes, yeah, exactly, Mark. Part of the core system allows you to act like a terrible DNS service. That is correct. That way you can test your fault tolerance on the application side. Yep. Yeah, you have to explicitly add that erratic plugin in. And the readiness plugin is being a jerk for me right now, but the erratic plugin never responds to being ready. So it will always fail it. So if the readiness check were working for me right now, and I called it when I had the readiness, I'll show it. at least. So if I put the ready plugin in this zone, it would always fail. /ready would always fail. So I'm leaving it out. Maybe I should put it in. It's not like it matters. But yeah, that way you can also test, does Kubernetes, does your cluster manager, scheduler, whatever, automatically kill things that are not ready? Let's see. So yeah, I can leave that in as long as I never hit erratic.example.org. It'll never introduce the latency. Only when I'm querying that zone does this plugin apply. Okay, let's see. All right, so I got this pulling from Route 53 now. We'll run that. Now if I do this, why is that just failing for me now? Interesting. I'm just going to do the one from my repo. We're mostly there. All right, it must be something I missed in my live coding, but that's why I do it ahead of time. We're basically at the end of that step anyway, so I'll just have to do a diff of what my live coding did versus what this did. But here we see that the DNS entry that I put in Route 53 is in fact what we're getting back here as an A record. We're also getting the authority section is test.rocdev.org. These are all the AWS name servers. We can also do text, and here we get, this is a test, which is exactly what we have here. Oh. I remember why the chaos plugin didn't work. I have to do the CH. Thank you. There we go. Now we get 1.6.9. Was ID, right? I can't remember. Version.bind, right? And ID.server. Oops. So ID.server is going to probably be the same thing. Oh yeah, that's the git commit. Version.binds. Yeah, version.server was the same one. Right. So the last piece, I should check the readiness. The last piece of this that I wanted to show was being able to fall through. That's a configuration of the Route 53 plugin. So here we can say, if I query something that Route 53 just doesn't know about, it's not in my config here. So I only have foo in here. Just fall through to the next plugin, and file is the next plugin. So if you have an older DNS service running on-prem and you want to migrate to have everything in Route 53, drop in CoreDNS, have it hook into Route 53 with some credentials, but then you can still have your existing static file if you're using bind or something like that. And I'll show what that looks like. I don't know anybody who can remember how to do this. So yuck. I mean, this is what configuring DNS servers, quote, used to be like in the olden days. Here we're saying we have a start of authority with A and B servers that are A records here. We have some MX records, name servers. We have C.test.rocdev.org because it's in the db.test.rocdev.org file. That's how you know it's magic. And we have a couple of other DNS records. So we'll try like www. And here we get a response back. And the name servers are here. One thing I didn't do, and live, see who the name servers are, it still responds with AWS as my start of authority, because the Route 53 plugin knows how to handle that, even though we very clearly know it did not serve that record. So that's, can't always trust it. But here in the authority section, we get the name servers that should be the authority for it. So that's kind of something to remember with the fall through configuration in Route 53. It knows how to handle start of authority responses, so it will, and it will not fall through for those. Something to keep in mind. Let's see, so we had some other ones in here. So foo, if we do a text record, that's going through AWS. I think we had an MX record in that file. No, can't remember. But also, so here's another example though that works. Whoops. None of them knew how to respond to that. So we're still getting the authorities coming from AWS. Oh yeah, let's check. And yeah, all right, so here's the readiness plugin working again. It is responding with a 503 service unavailable because I have the readiness check in the erratic section. So if I remove that, call it again, I get an okay. So yeah, this should, now it works again. Let's see, any questions I can address, or at least try to?
So I'm curious, you can use CoreDNS as an authoritative server as well, that's correct, or no?
Yeah, as long as it has the entire zone.
Right, so I know that like Kubernetes deploys multiple pods of, CoreDNS. So what, how do updates work? So like with bind, you would use like tsig to sign DNS updates, and something can dynamically update the zone that way. So does CoreDNS do the same thing, or is it using like a different backend storage model that lets any of the CoreDNS instances accept updates? Like, is it using it like an API instead of traditional like DNS signed updates and stuff?
Yes. So in Kubernetes land, there's a Kubernetes plugin, and that'll automatically be pulling from the API server and pulling in updates. There's also the auto plugin, so you can, as it may be a little small, enable serving zone data from the RFC 1035 style master file, which is that ugly thing that I showed earlier, but it's automatically picked up from disk. So if you can shove in new things on disk, auto plugin will pick them up. There's also auto path, which is kind of similar to auto. And let's see, there's a couple other ones that allow you to do dynamic. Way back when, I used SkyDNS in the CoreOS days, and that worked by watching a, what are they called, directory in etcd, and then it would automatically pull in the DNS records. So you can also do that too. It's using the same path in etcd that SkyDNS used to do, and it pulls all of the information from that. You also have a hosts option. So yeah, there's a lot of options. So you can serve zone data from something that looks like an Etsy host style file.
Cool.
One other cool one that I didn't really show is like load balancing. So if you have multiple A records or Quad A or MX records, and that plugin is enabled for that zone, it'll just randomly pull one. And by random, I mean, I think it only supports round robin, so it's very predictable. But anyway, yeah, round robin. That one's kind of cool because it also works with other plugins like Forward and also Route 53. Oh, and if for some reason CoreDNS seems slow to you, the pprof plugin publishes profile data. And the reload plugin for changes to the core file itself. Secondary. Yeah, there's a lot of them. DNS over HTTP. I haven't done that, Mark. In my reading through CoreDNS, I have seen people doing that, and I don't know anything about it. Oh, loop is a cool one too, detecting loops. All right. Any other questions? Cool. I'll stop the recording.